In this lesson, we're going to go over some homework problems involving total ionic and net ionic equations. These selected problems are from assignment 23-6QB. We'll go over problems 6-60 and 6-69. In previous videos, I've talked about solubility rules and writing equations for double displacement reactions, the total ionic and net ionic equations. Here we're going to see some applications of those concepts. Let's look at the first problem. In 6-60, the problem says when calcium hydroxide neutralized with sulfuric acid, the salt produced is insoluble in water. Write the balanced molecular equation illustrating this reaction. They want the physical states of each element or compound. Now, I've talked before about memorizing the polyatomic ions. In addition to answering the questions, the knowledge of the formula and charge of polyatomic ions will help when presented with a question like this. You need to know the formula for calcium, the charge, that's easy from the periodic table. Hydroxide is a -1, so calcium hydroxide is CaOH2. Sulfuric acid has the formula H2SO4. If you don't know these formulas, it's very difficult to solve a problem like this. So we know in a double replacement reaction, the ions in the reactants change partners. Calcium and H+, they won't combine because they're both positively charged and they'll repel each other. That means that calcium 2+ will combine with the sulfate, making calcium sulfate. That's one of our products. The 2OH combined with H+, that makes water, H2O. In fact, from this reaction, we'll get 2 water molecules. This is an acid-base neutralization, and you're always going to get water as one of your products in an acid-base neutralization. Our molecular equation is our given reactants going to CaSO4 and 2H2O, and that's balanced. Now the question said the salt produced is insoluble in water. That's a very valuable clue. One of the products is water, so the salt has got to be calcium sulfate, and it's not soluble. Checking table 6-3, that says that calcium sulfate is slightly soluble. The balanced molecular equation then, including the states, we've got CaOH2 aqueous, H2SO4 aqueous, CaSO4 solid, and 2H2O liquid. Water is designated as a liquid. So the next part, they ask for the total ionic equation. When we write the total ionic equation, we separate the aqueous reactants and products into individual ions. The subscript means that the ions are separated by water molecules. There is our molecular equation again. So if we take our aqueous reactants and products, separate them into their aqueous ions, here's what we get. Calcium 2+ aqueous plus 2OH- aqueous as well. Don't say OH2. We get also 2H+ aqueous and the sulfate anion SO4 2- aqueous. Our products, CaSO4 solid, that stays together, plus 2H2Os. Those molecules stay together as well. That is our total ionic equation. It takes some time, and you want to make sure you include your charges and your states, but it's not conceptually difficult. The next part asks for the net ionic equation. We find the net ionic equation by taking the total ionic equation and canceling the spectator ions. The spectator ions are exactly the same on both sides of the arrow. There is our total ionic equation. I'm looking for the exact same species on both sides, and I don't see any. What do we do now? Well, if there's no spectator ions, the net ionic equation is the same as the total. So for the answer to this problem, we'll just put this same reaction in. This is not common, but you will see problems like this, and here is an example. Now let's do the next problem, 6-69. It gives us a series of ions and asks which net ionic equations occur. We couldn't do this in a lab because if we mixed a whole bunch of solutions together and made a series of different solids, we would just see a beaker full of chemical sludge. So let's look at that question. So our ions that we have: ammonium, magnesium, cadmium, carbonate, sulfide, and bromide. So we need to choose the net ionic equations for any reactions that occur. So this is an application of the solubility rules. Which of these combinations of cations and ions will be solid and fall out? So the first two reactions, let's look at these each reaction at a time, involve carbonate. Most carbonates are insoluble, except when combining with group 1A or ammonium. So cadmium and magnesium are not in group 1A, so yeah, those first two net ionic reactions will occur. So a common sense check: cadmium and magnesium, both +2. Carbonate is -2. The attraction for those ions is pretty strong. Those will probably not be soluble and give us solid precipitates. So let's uncheck the first two boxes. So next reaction. Most chlorides, bromides, and iodides are soluble except with silver, mercury, or lead. Cadmium, not one of those three heavy metal ions, so cadmium bromide is soluble and will not form a precipitate. So we will leave that box unchecked. Okay, the next reaction, ammonium, NH4. Everything with ammonium is soluble. So that fourth reaction will not occur. We will leave that box unchecked as well. The next reaction, most sulfides, like carbonates, are insoluble, except with ammonium or group 1A. So this fifth reaction will occur. Cadmium plus sulfide will make a solid cadmium sulfide. Check that box. The final reaction. This is a trick question. Most sulfides are insoluble. Magnesium is not group 1A. If you look at the table, it says that group 2A metals are soluble with sulfides, but this doesn't even happen in this case. Magnesium sulfide reacts with water, producing hydrogen sulfide and magnesium hydroxide. Regardless, we will not check this box and don't expect to see anything like this on any assessments. I think Wiley's just being Wiley. So most problems are not that tricky. If you understand the solubility rules and practice the homework, you'll be able to answer the vast majority of homework and assessment questions. Don't get hung up on these one or two tricky problems. Practice, make sure you can do them on their own, and of course contact your course mentors if you have any questions. Here's our information once again. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.